And then we'll go ahead, let's see, and we will, Noel, I'm glad you're doing well, Noel. Let's see, and then we'll go ahead and get started. So like I said, you guys, I do have my power cord today, so we should be good. No running out of power today. And what we're going to do, y'all, we're going to cover 3.1 and 3.2. Guys, at any point in time as we're going through this stuff here, if I say something that doesn't make any sense and you got questions, please stop me so that we can go over it, okay? I want to make sure that everybody's good, okay? So let's see, 3.1 is defining the derivative. I think we were talking a little bit about this on Monday, and then all of a sudden the lights went out on us, right? So let's see, recognize the meaning of a tangent to a curve at a point. We're going to calculate the slope of a tangent line. We're going to talk about identifying the derivative as the limit of a difference quotient, calculate the derivative of a function at a point, talk about velocity as rate of change, explain the difference in average velocity and instantaneous velocity, and estimate derivative from the table of values. Let's see. Whoa. So again, this is just a little bit of history here. You know, Isaac Newton, Leibniz, these were the guys who were kind of discovering all this business, but we're gonna bypass that, and we're gonna get into tangent lines, okay? So it says we're gonna talk about the notion of secant lines and tangent lines. So earlier in chapter 2, we talked about the slope of the secant line at a point A and F of A to estimate a rate of change. You're good, you're good. Or the rate at which one variable changes in relation to another variable. So we can paint the slope of the secant line by choosing a value of x near our point A and drawing a line through the point. So, you know, we had something like this before. I'm just going to kind of draw a rough graph. Here's my graph, right? And suppose this is a value of A. Here's another value of x. So this would be f of A, and this one here would be f of x, and then we'd have a secant line, right? And the idea here, y'all, is this is what we're calling this thing the difference quotient, okay? So this is roughly what my graph would kind of look like, right? And it says we can also calculate the slope of a secant line to a function a by using the equation and replacing the x with this value of a plus h, where h has a value that's close to 0, okay? And if we were finding the slope of the secant line, and I'm going to kind of zoom in over here or move down so we can see the graph, okay? And it's just roughly the same kind of a graph that I drew earlier. So let me kind of just get all this on the same page. Okay, so here's the first one. Here's like my A, here's my X, right? Here's my graph, and then I'll do it the same kind of color they're using. Here's the slope of my secant line, right? And the idea of what they're saying is, if we pick these values of X that are close to the value A, we're going to be approaching kind of like a limit, and we're going to be finding the slope of something we call a tangent line, okay? Now remember, a tangent line is a line that just barely touches the curve. It doesn't pass through it, it just kind of touches that curve at a given point, right? So you could see that if I started picking numbers closer and closer this way, so if I had another value, say X here, and then I found that line, it's getting closer and closer to what we would call a tangent line, okay? That's right. We can keep taking values closer and closer. So that's right. We have an infinite number of choices to pick for our values of x. The idea is, again, we're getting closer and closer to that value a. Okay. Now, another way they're saying that we can do this, just another description of it, is, again, suppose this is my value a. We're going to take values of a plus h. But the value of h, y'all, are going to be numbers that are close to 0. So if you think about it this way, the distance right here is h, right? Because if this point is a and this point is a plus h, then it's just a difference of h right there, right? And so the idea here is what we're saying is, if we make this value of h values that are close to 0, then this point is moving kind of to my left, right? And that's kind of the same thing that was happening here. It's just two different ways of interpreting the same idea, okay? So we have two different quotients. One of them is f of x minus f of a over x minus a, and one of them is f of a plus h minus f of a divided by h, okay? So these, again, they're still telling you the slope of the secant line, just two interpretations of it, okay? So now let's take a look here. It's saying we can see as x approaches a, the slope of the secant lines provide better estimates of the rate of change of the function at a. Furthermore, we can see the secant lines themselves approach the tangent line. That's kind of what I was trying to draw in the previous picture, right? And again, so as we start taking those values closer and closer, this right here, y'all, is what we end up with. This is giving me the tangent line at a particular point, okay, at a particular point A. Because what we're doing is, in essence, we're saying, let's pick values that are closer, and let's do another one that's closer, so on and so forth, right? So we're taking like almost like little limits, right? We're getting closer and closer to that value A, and then we're finding the slope of the tangent line right there. All right, so let's see if we can do an example here. So it says, in this picture, we have a graph of f of x equals the square root of x, and its tangent line at the point 1, 1, okay? So they're already given us this. We're going to figure out how we would do this in a minute, but they're giving us these values so far. So here is the graph of the square root of x, and the tangent line is this equation right here. Y is equal to x plus 1 all over 2. And you can see what in essence what they're doing, y'all, is they're zooming in. If you notice here, this interval on the x-axis goes from 0 to 4. Look at the interval on this x-axis. It goes from 0 to 2. If you notice, if I look at, say, this picture right here, you can see, let me clean up some of this mess because it is a little bit messy. You can see what we're looking at right here is, here's that tangent line, right? What we're going to do is we're going to show that as we zoom in, that tangent line almost replicates the curve, even though it's a curve, it almost replicates it as we zoom in. So as we start going closer and closer and closer, you can see what's happening, right? So look, now we're looking at, say, from 0 to 2, and we're going to say, let's look at this interval, say, right here. And as they do that, here's the graph, right? So the blue graph, y'all, and I know it's kind of hard to see, but here's the blue graph of the square root of x, and then that kind of orangey graph is the line x plus 1 over 2. As I get in a really, really tight interval from 0.9 to 1.10. So think about it in terms of money. It's a 20-cent difference, right? From 90 cents to $1.10. There's only 20 cents in there, right? So we're looking at a really, really tight interval. What we're saying is the graph of the square root of x behaves a lot like x plus 1 over 2 in that little piece, okay? Because it looks like the line and the graph are almost the same. I mean, you can kind of tell, I don't know if y'all can see as well that the color is as good up there or not, but you can kind of tell the difference. Like there's a little bit more of the orange line here, and there's a little bit more of the blue over here, but you can see that those two things look very much the same, right? And it's going to even look even closer. It looks like they're going to be almost like this, right? Yeah, that's exactly right. Good, John. So, and now if you notice right here, y'all, it says for values of x close to 1, the graph of f of x equals the square root of x, and the tangent line appear to coincide, right? That's in essence what we're saying. They look almost the same. See? So let's see if we can get into like how do we actually find tangent lines and all that kind of good stuff. So we talked a little bit about, we said there was two ways to talk about that secant line. And one of them was the f of x minus f of a all over x minus a. Now, we want to find the tangent line, y'all. What we're going to do is we're going to take the limit as x approaches a of that different quotient, okay? Because my x values are getting closer and closer and closer to a. Now, another way we can find our tangent line, the slope of our tangent line, is we can use the second difference quotient, which is f of a plus h minus f of a divided by h, and we're taking the limit as h approaches 0. If you remember before, I'm going to kind of scroll back, and I'll come back to where we were. Here we go. We said if remember, the distance here is h. Well, as that distance gets smaller, then we're going to be approaching that tangent line. Okay, that's in essence what we're saying. So let's see if we can actually figure this out and apply it to a problem or two. All right. So here's the kind of first example that we're going to work out. We're going to find the equation of the line tangent of the graph f of x equals x squared at x equals 3. Okay. So y'all, what we're going to do for this problem, we're going to use the first method. Okay. So the first thing I'm going to do right here, y'all, I'm going to write the slope of the tangent line is equal to the limit as x approaches a of f of x minus f of a all over x minus a. Okay? What we're going to do is we're going to apply it to our problem. Okay. Our x value is supposed to be approaching what number in this case? 3. Okay. So this is going to be, I'm sorry. Here we go. So we're going to write f of x minus f of 3 all over x minus 3. Okay. All right, we already know what f of x is equal to. F of x all is equal to x squared. Minus, now we need to find f of 3. So question, if we know that f of x is equal to x squared, anybody know what f of 3 is? 3 squared, which is, sorry, how much? 9, very good. So that's going to be my 9 right there. Okay. All over x minus 3. Okay. We're almost done, y'all. Okay, yes, ma'am. Because that's the function that I have right here. Is that better? And then are you okay how we found f of 3? Because we're plugging in the 3 right here. Good? Okay, awesome. You're welcome. So guys, take a look right here. X squared minus 9. So I don't know how much of the factoring stuff you guys remember. And the only reason I say that, y'all, was last semester I taught pre-cal. And I was telling my pre-cal class, those of you who are in pre-cal, you might remember this, but I was like, I feel like my students in my Math 100 class would do really well in certain parts of pre-cal because all we do in Math 100, a big part of what we do in Math 100 is practice, right? So if you remember factoring, great. If you don't, I'm going to share with you guys like a little video, like another one of my YouTube playlists, and I'm going to tell you, hey, in these sections here, I do factoring stuff. So if you need to do some reviews, you can definitely do that. All right, what can we get rid of here? What's the common factor that we're going to get rid of? Yeah, the minus 3, okay. So now we're going to have the slope of the tangent line being the limit as x approaches 3 of x plus 3. So what is that limit going to be equal to? This. Okay. Now, we're not quite done yet, y'all. What we found at this point, let me get rid of that. What we found at this point was we found the slope of the tangent line. But I want you to notice what they're actually asking me to find. They're actually asking me to find, can we find the equation of the line, okay? So, y minus y1 equals m minus x1, okay? So I'm going to show you the easy breezy curvicle way of doing this. Now, we already know our value of m, don't we? We just found our m to be what number? 6. Okay, so right here, y'all, I'm going to put a 6. Okay. Now, the values that we need to still label are these here, the x1 and the y1, okay? Well, the x1 is given to me right here, y'all. Remember, we were doing this at x is equal to what value? Okay, so the x1 is going to be a 3. The y1 is when we evaluated that function at 3. And we ended up with 9, didn't we? Okay. So now, let's go ahead and solve this equation for y. So I'm going to have y minus 9 equals, everybody agrees, 6x minus 18. And then we can add 9 to both sides. And we end up with y is equal to, what is that, 6x minus 9? Minus 9, right? There you go. And there's the equation of our line, tangent at that point. All right. So far we doing okay? John, am I good? Okay. So are you okay how we got up to this step here? By canceling out the x minus 3? Okay, we were good there? And then let me ask you a question, John. Are you okay that we got the limit of x plus 3 as x approaches 3 to be equal to 6? Because we're basically substituting x equals 3, right? Because that's the number we're approaching. So we're saying, well, look, if we were to plug in a 3 right here, 3 plus 3 would give me 6, right? Okay. So now, this is the part where we're going to work on. This part right here. So that equation right there, y'all, let me just kind of do this on the side. This is what we call the point slope equation, okay? And it's y minus y1 equals m minus x1, okay? Where m is our slope, right? And the point x is the point on our line, right? Okay. So now my m is my 6, right? And I remember over here, John, when we plugged in 3, didn't we end up with 9? So really my point is my 3, 9. So I'm putting the 9 where my y1 was, and I'm putting the 3 where my x1 was. And then we're going from there. Does that make more sense? Okay. I'm sorry, you forgot the what? Oh yeah, f of x and y do the same thing, right? Yeah, f of x and y, guys, mean the same thing. So if your name is Antonio and we call you Tony, it's the same thing, right? Right. So think of f of x as like Antonio and y is like Tony, right? Okay. So look, y'all, we're going to do the same problem, exactly the same problem, but we're going to use the other equation. We're going to use the equation 3.4. I'm going to write it down so you don't have to worry about it. We don't have to go back and scroll. Okay, so what does the equation 3.4 says? It says we're going to take the limit as h approaches 0 of f of a plus h minus f of a all over h. Okay, supposed to be an h right here. Okay, so first question. Everybody agreed that f of 3 is still equal to 9? Right, because it's the same function, right? We're still looking at f of x equals x squared. We're still looking at x equals 3. So we're still dealing with the same equation that we were dealing with in the previous problem, okay? So now I want to show you something right here. Do you see how this part says f of a plus h? Remember, my a is my number 3, right? So this is what we're going to do. We're going to write 3 plus h squared. What am I doing? All I'm doing is I'm saying my a is the number 3, h is still h, and I'm plugging it into this function directly. So this function says f of x equals x squared, right? So f of a plus h, wouldn't that be a plus h squared? Right, because f of x is equal to x squared. And isn't my a equal to 3? So if I plug in the 3 where the a is, it would be 3 plus h squared. We're doing okay so far? Okay. Minus, what did we say f of a was? 9. Okay. What do we have on the bottom? There we go. Okay. We're going to go real slow, y'all. We're going to go real slow, like juvenile, slow motion. Okay, right here. Y'all are too young to remember that song. But check this out. 3 plus h squared. So we're going to do a little sidetrack over here. What is 3 plus h squared mean? It means 3 plus h and 3 plus h, right? And you say, oh, remember the full method? Man, they taught us the full method left and right in high school, didn't they? So 3 and 3 is 9. 3 times h is a 3h. So we got that one done. H times 3 is another 3h. And h times h is a, what, h squared? Right? Can I combine the two in the middle? So what's 3h and another 3h? There you go. Okay. So that's my scratch work, right? We were doing the 3 plus h squared. We just did it on the side because, we don't have to do every single step right on the main part of my work. So now look, y'all, I'm going to scroll back over here. And we're going to say we had a 9 plus 6h plus h squared. Wasn't that this part right here? Right? What do we still have after that, though? Minus 9 all over h, right? Are we good so far? Okay. Guys, what's going to happen to my 9? We get rid of them, right? Boom, boom, go away. So now we're going to take the limit as h approaches 0 of 6h plus h squared all divided by h, right? Because those 9's canceled out. Now, a couple of ways we can do this part right here, okay? I'm going to show you the first way, and I'm going to show you the second way, and you tell me which way you like better. You got to pick one of them, okay? First way, write it like this: 6h over h plus h squared over h. Because we're separating the fraction, right? If I have two parts on the top over the bottom, I can just write them with this one over that and this one over that. Wouldn't these h's cancel here? Right, because I got one upstairs and one downstairs. Okay. So this would be the limit as h goes to 0 of 6 plus, isn't h squared divided by h just another h? Because there's 2 on the top and 1 on the bottom, so if I cancel the one on the bottom with one of them on the top, I'd still be left with one upstairs. Okay. Now let me ask you a question. As h approaches 0, what is the limit going to be equal to? Of 6 plus h. Remember, h is getting closer and closer to 0. So aren't we going to be substituting the value of h to be what number? So then what would my limit be equal to? It would be equal to 6, right? Let me ask you a question. When we did it using the first equation in the previous problem, didn't we still get our slope to be 6? Right? Isn't that the same slope that we got before? Okay, so guys, I'm not going to run through, okay, now let's go ahead and plug in the slope in the point slope form because we had already done that part. The main thing is, can we still come up with the same slope? Does that make sense? John, are we doing good? Am I loose? Because we're taking the limit as h approaches what? 0. So if h is approaching 0, isn't it really all I'm doing here, John, is plugging in a 0 right there? Right, but remember, how did we do the problem that we did before? When we were over here, and we were doing this part, and we were taking the limit as x approaches 3. As x is approaching 3 of x plus 3, didn't we say our answer was, right? Because if you're taking the limit, aren't you essentially plugging in values that are closer and closer and closer to 3, right? So if you take a number that's really close to 3 and you add another number and you add 3 to it, wouldn't that limit be 6? Okay, so now let's come back over here. If I'm taking the limit, and let me do it like this so that I can clean it up a little bit. If I'm taking the limit as h is approaching 0 of 6 plus 8, isn't this part getting closer to 0? So wouldn't the whole thing be getting closer to 6? Does that make sense? Okay, good. So guys, I told you one way you can do it, divide each piece by the bottom, and then just cancel your h's, right? I'm going to show you the second way, and you're still going to end up the same answer. I'm going to ask you a question. Is there anything I can factor out of the top? Is there anything that 6h and h squared both have? They both have an h, right? Right? And then at this point, you can say, stop. Get rid of those. And we have the limit as h approaches 0 of 6 plus 8, which is this equals 6. Okay. Which way do you like better? This way or the other way? You get to decide. Why? Because you're going to end up with the same thing either way, right? So it's not really important, well, oh, this way is better. Okay, then do it that way. Or the other way is better, then you do it that way, right? You're going to find which is easier for you. Some people say, you know what, just divide each of them by 8. That works for me. Some people say, let me factor it out. That works for me. You find the one that you like best. Okay? All right. Now, if you remember, y'all, when we did the problem earlier, when we just got finished doing a little while ago, and I'm going to kind of scroll back up here. Remember the equation of our line weight? It was y equals 6x minus 9, right? And so what I'm going to do is I'm going to scroll down right here, and here is the tangent line at f of x at x equals 3, right? So what does this mean? You can see that right here, y'all, we're touching the graph just at that one point. This is the equation of y equals 6x minus 9. That's the equation of our tangent line. What it also tells me is that if I were to zoom in a whole lot, and I can't really zoom in anymore, but if you can imagine me zooming in just a little bit more, say look right from here to say right here. It's really hard for me to distinguish where's the blue line, where's the orange curve, because they look almost the same in that little piece. Does that make sense? They look almost the same right there, right, as I zoom in. And that's the graph of my tangent line. Remember, the tangent line hits the graph at that one point. But as I zoom in, they look almost the same. Okay. So let me zoom back out. Whoa, there we go. And there's the graph of our tangent line, right? Okay. Tell me. That's right. H represents that distance. A would be my point 3. And then what we're doing, John, is we're taking, say, something like 3 plus h, somewhere right about here. But the value of h is getting closer and closer to 0, right? So it's really small. That's right. Right? So another way to look at it, y'all, and I'm going to kind of just draw, again, a general picture here. So here's my graph, right? Actually, I'll make a better graph. I can do a better job than that. Okay. So here's a plus h. Okay. Do you agree with me that there's the secant line? Okay. So what we're saying is now is, look, remember the distance between here and here is h, right? So if we were to move this point, if we were to move it closer, so now I'm going to say this is h plus h, right? And, I'm doing this kind of freehand, right? But if you could think of this graph, let me do it here so I can make it a little bit thicker. think of this graph almost like the train track that's outside, okay? And if I could take this point and move it along that track until I get closer to this point, you're going to see, so if I moved it over here, there's that line. If I move it over here, there's that line, right? If I move it over here, there's that line. But I'm kind of trying to get closer and closer, and that's going to give me that tangent line. As I make that value of h down really, really, really small. Does that make sense? Good. Excellent. Good questions, y'all. I think understanding the concept and just being able to visualize it helps out a whole lot. It was 6 was our slope. And that's right. It's the rise over the run. So remember, the 6 was our slope. So this was the slope of the tangent line at the point when x was equal to 3. Right? So at x is equal to 3, that was the slope of the tangent line. That's right. That's right. So right here, you would go up 6 and over 1, right, to draw your tangent line. Does that make sense? Now that's the tangent line at that particular point, right? So my slope is going to change based on the point that I'm looking at my graph, right? So guys, you can see that. So you can see the slope here is 6, right? That line is, I don't want to call it super steep, but it's steeper than, say, I wanted to find the slope of the tangent line at 1. So if I were to do that one, wouldn't you, the green line is more steep than the red line? So the red line is a tangent line. It's a tangent line when x is equal to 1. I would have a different slope there, right? So I'm finding the equation of the line tangent to the curve at a particular point, right? So the slope is not always going to be 6. The slope in this case was 6 when x is equal to 3. But if I was doing it at x equals 1, my slope would be different, okay? It would be less. It would still be positive, because if I look at my red line is going up. So I know that my slope is positive, but it would be a number that's smaller than 6. Okay, it'd still be positive, but something smaller than 6. I don't know, 2, 1, something like that. Something smaller than 6. Okay. Okay. So let's try the same thing here. We're going to find the equation of a tangent line to the graph f of x equals 1 over x at x is equal to 2. Okay. So y'all, we have a couple options we can do. One of them is we can find the limit as x approaches a of f of x minus f of a divided by x minus a. The problem that we did a little while ago, we basically did 2 versions of that problem, right? And this was like the first way we did it. So we can do it like this, or we can use that other difference quotient where we have the f of a plus h minus f of a all over h, and you take the limit as h equals to 0. But you're basically going to use one of those 2 versions. So again, before I go on, let me explain what I'm talking about. When we're going to find the equation of the slope of our tangent line, you get to choose. Do I want to choose formula 1, or do I want to choose formula 2? The only thing that's going to be different, look at as my limit. Here, my limit is x is approaching a. Here, my limit is h is approaching what number? 0. Now, I want you to notice something. As x is approaching a, wouldn't the bottom number here be getting closer and closer to 0? Right? Because if the number is close to 8 and you're subtracting that same value, then the bottom number is going to be 0. You see what I mean? So like if I'm going to make this up, suppose a was 5, right? So I have a 5 here, and I'm taking the limit as x approaches 5. Look at the denominator. Wouldn't that part be going towards 0? Right? Because as x approaching 5, 5 minus 5 is going to be getting closer to 0. What's my denominator going to be approaching here? 0 as well, right? Which one so the denominator is still going to be approaching 0, right? Which formula do you want to use? You get to decide. Do I want to use the first one? Do I want to use the second one? You're going to end up with the same thing. Remember, we did it right now, and for both of them, you still got the slope being 6. You just get to choose which one you're going to use. Does that make sense? Okay. So look, let's come back and let's do our problem that we got. Here we go, right over here. Okay, so guys, I'm using the first formula. I'm kind of doing the first one. Okay, so the first thing I need to do is I need to find f of a, which is, in this case, 1 over a, but my a number is what? 2. So f of 2, everybody agree, is just 1/2? Okay. So look, we're going to take the limit as x approaches 2, f of x. F of x was 1 over x, right? Minus f of a. What was f of a? 1/2. Very good. All over x minus, what did we say our number a was again? But the x number, the a number. 2. There you go. Okay. Okay. So now let's do this piece. Y'all, we're going to fix that part right there. I'm just going to do what I put in the green box. I'm subtracting 2 fractions. And one thing I remember is that anytime I add or subtract fractions, you have to have a common what? Okay. Anybody know what the denominator between x and 2 is? We got to multiply them. We got to multiply them. We got to go 2x, okay? So now, let me ask you a question. What do I have here that I didn't have over here? So we're going to put the 2 upstairs because we're missing it, right? What do I have over here that I didn't have over here? So we're going to put the x on top. And look, we got a minus right there. Okay. Now, I'm still just dealing with the top. We'll come back and worry about this x minus 2 downstairs in a second. Okay? Y'all agree that we can write this as 2 minus x all over 2x? Right? Because we're just writing it as a single fraction all over x minus 2. Because we still have that x minus 2 on the very bottom part, right? Okay. Now, I know what you guys are probably thinking. You're saying this right here looks horribly ugly because there's a fraction with another fraction. Remember what a fraction means I'm doing. A fraction means I'm adding, subtracting, multiplying, or dividing. Dividing. So we're really dividing by x minus 2, right? So do you remember how you divide a fraction? Multiply by the reciprocal. So we're going to put 2 minus x over 2x. The reciprocal of x minus 2, y'all, is 1 over. There you go. So we're going to do a little bit of factoring here. That's right. So, y'all, I'm going to show you something. I'm going to rewrite this 2 minus x. I'm going to write it as a negative x plus 2. Okay. All I did is switch these two around, right? The x is negative, put it in the front. The 2 is positive, put it in the back. So we didn't really do anything horribly. You know what I mean? We just switched it. Yes, sir. Uh-huh. Yeah. So think about it this way. Couldn't I think of this guy over 1? Because I can think of any number over 1, right? 7, 7 over 1, 11, 11 over 1, x minus 2, x minus 2 over 1. So when I'm dividing this big fraction, I'm going to multiply by the reciprocal of this, which is just that 1 over x minus 2. Does that make sense? Okay, so guys, we're almost done here. Let's check this part out. I'm going to look at this top part again. I'm going to factor out the number negative 1. When we factor out a negative 1, in essence, what we're doing is we are changing the signs upstairs. So here's my negative. Here's my x minus 2. Let me ask you a question. Is this x minus 2 going to cancel with that one there? Okay. Did you still have a negative 1 on the top? Yeah? Okay, good. Now remember, y'all, we're taking the limit, I got to write my limit here, as x is approaching 2. So if we're taking the limit of this expression right here, so x is approaching 2, remember, we're going to be plugging in the value x equals 2. What value am I going to end up with? Remember, you're plugging in what number? I'm sorry, say it again. Very good. Negative 1/4, right? You're plugging in the number 2. 2 times 2 on the bottom? 4. Negative 1 upstairs, negative 1/4. Okay. Remember, y'all, what did we find here? We found the slope, right? This is just my m value, okay? This is just my m value. So look, over here on the side, what am I going to do? I'm going to do my work to find the equation of my line. Y minus y1 equals m x minus x1. Okay, so remember, we already know our slope is a negative 1/4. Okay, all we're going to do now is plug in values for y1 and x1. Okay, so we say, hold on, what are those values for x1 and y1? Those same values we started off with, right? 2, and what's the y value? There you go. No, but I could have stayed home. You already know what to do. 1/2 right here, 2 right here. Okay. So now let's go ahead and finish solving this problem. We're going to go y minus 1/2, and we're going to distribute. So negative 1/4 times x, negative 1/4 x. Anybody know what's negative 1/4 times a negative 2? Positive half. Excellent. Good. Okay. Last step, we're going to get rid of that minus 1/2 by adding the 1/2. And so we end up with y equals negative 1/4 x, 1/2 plus 1/2. 1. Very good. And you got it. Okay. All right. So we're not quite done yet, right? But I'm going to show you, we finished the problem because we found the equation of our tangent line at that particular point, right? Now, guys, look at the equation we came up with. We came up with y equals negative 1/4 x plus 1, right? So now, hey, take a look. And then we get the same thing, y equals negative 1/4 x. So they wrote it as negative x over 4. But I know you guys know already the number in front of that x is a what? Right? Same thing. Is it any different? No. Antonio and Tony, same person, right? Susanna and Susie, same person, right? Now again, y'all, look, remember we were doing this at x is equal to 2, right? So here is the graph of our tangent line, right, at x equals 2. You can see it. Again, y'all, if I were to zoom in a whole lot, you can see how at that particular point, right, if I were to take more narrow windows, the graph and the tangent line look almost the same at that point, right? As we were to keep zooming in, if we could go in, magnify even further, that's kind of what's happening. Okay? Well, we would have to go through the process, right? You see, we'd end up with the same thing. That's how we could check it, right? Well, remember, so do you, if you really want to know, we would do that process. You see what I mean? Now, the slope might be the same. The line wouldn't be the same, right? But the slope could be the same. Yeah. Good, good, good. Okay, so now let's take a look here. And we're talking about the derivative of a function at a point. So it says, the type of limit we compute in order to find the slope of a line tangent to a function at a point occurs in many applications across disciplines. These applications are in velocity, acceleration in physics, marginal profit functions in business, growth rates in biology. Limit occurs so frequently that we give this value a special name. We call it the derivative. And the process of finding the derivative is what we call differentiation. So it says, let f of x be a function defined in an open interval containing a. The derivative of f of x at a, this is how we denote it. We use f with a little apostrophe. Quick question. Did any of y'all ever have calculus in high school? No? Okay, that's all right. I was just curious. So the way we read this part right here, y'all, f prime at a. Okay? That little apostrophe, prime. That's all you got to do, f prime at a. So remember, we had two options when we're going to find the derivative. We can use either the first one, or we can use the second. Okay? So this is how we would find that derivative. Okay? So now let's see. So it says estimating the derivative for f of x equals x squared. Use a table to estimate f prime of 3 using equation 3.5. Okay. So what we're going to do here, y'all, we're going to use this equation right here. Okay? We're going to say f prime at 3 is equal to the limit as x approaches 3 of f of x minus f of 3 all over x minus 3, right? Okay, so what we're going to do here, y'all, is we're going to use a table to do this. And I'm going to kind of give you an idea on how we're going to be doing this part, right? So remember, didn't we say, what's our function for f of x? What is it equal to in this case anyway? What is my f of x equal to? X squared, right? Good. Okay. Do you remember what f of 3 would be equal to? If you were to plug in a 3 into that function, what would you end up with? But 3 squared? 9. Good. All over x minus 3. I'm sorry, this is supposed to be a 3 down here. That's my bad. Okay. So what we're going to do, y'all, we're going to make a table. So I'm going to grab my equation, my calculator real quick. Okay. Let me turn this guy on. Clear it. Let's see, do I have any equations written here? Not yet. Okay. So I'm going to type in this entire expression. I'm going to put x squared minus 9 divided by x minus 3. Okay. There we go. So we got it. Let's do that in. Okay, perfect. Now, remember, I'm going to come to bars, and I'm going to go to the y bars, and I'm going to go to my function, y1, and we're going to evaluate this at values that are close to 3. So remember, we did this earlier in the couple of weeks that we were online. We made tables similar to this, right? And we said, look, let's take some numbers that are close to 3 from the right. So we're going to take values that are a little bit bigger than 3. Didn't we take numbers like 3.1, right? Look at the slope that I'm coming up with, 6.1, right? And then we said, okay, look, let's try the same thing here. And let's do 3.01, 6.01, right? And we can keep playing that game, right? And let's do this one more time at 3.001. And we can see that we're getting values that are really close to 6, right? And then we could say, well, hey, you know what? I know that's what's happening on the right side. Is the same thing happening on the left? So we would take numbers that are slightly smaller than 3, 2.9, let's see, 2.99, right? And if I were to put 2.999, what number do you think we'd end up with? 5.999, right? We can kind of see that's in essence what we're doing here, right? That's what it means by doing this with a table. And again, this is not something we haven't done before. We did it back in the couple of weeks online. But all I'm really doing, y'all, is I'm using this equation right here, and I'm writing that as my expression, and then I'm taking my limits, right? And you can see that my calculator helps me a whole lot because I'm not having to do this, manually, right? And at this point, you don't want to be doing that manually. Okay, so now let's do another one. Let's do another derivative here. It says for f of x equals 3x squared minus 4x plus 1. Yes, sir. Well, what was the answer that I was coming up with? You tell me, John. I want you to look at the values that I was coming up with. There you go. And now look, what were the values that we're approaching? They're approaching what number again? You just said it. Okay. Now, I'm going to ask you a question. Look at the function that we have here, right? And we're finding the derivative at 3. Let's scroll. That is the same function at 3, and we found the derivative, and what was it equal to? 6, right? And we did it over here using the other option, and we still got 6, right? So that's what we should be coming up with. Yeah, equal 6, right? We're doing it numerically, right? Because we're doing a table, but we know that that's what we're getting, right? And we did it algebraically the first time, so we know that's the number we should be coming up with, right? Yes. Of course. And I'll even put it right here. This is equal to 6, right? We'll put C. That's right. Okay, but remember, that's what we're approaching. But remember, didn't we do the same thing over here? And weren't we able to, when we did it, say, here we go, right here? Weren't we able to cancel out that factor? Right? And so now, as we're approaching 3 of this expression, isn't it going to be equal to 6? There we go. Yeah. Okay, so look, let's come back over here, and let's try the next one. So it says, finding the derivative for f of x equals 3x squared minus 4x plus 1. Find f prime of 2 using equation 3.5. Okay, so I'm going to come back real quick, y'all. I want to see which is equation 3.5. It is this one right here. Okay, the one we just used. Okay, so I'm going to write it like this. We're going to find f prime of 2, which is going to be equal to, the limit as x approaches 2 of f of x minus f of 2 all over x minus 2. Okay? This is still equal to the limit as x approaches 2. Now remember, y'all, my f of x is that expression right there. I'm just going to write it in parentheses right now, 3x squared minus 4x plus 1 minus f of 2. So we need to evaluate the function at x is equal to 2. Okay, so let's do that. 2 squared is times 3, 12. Minus 4 times 2 is plus 1. Let's see. 12 minus 8 is plus 1 more is boom. Okay. All over x minus 2. So f prime at 2 is equal to the limit as x approaches 2 of, let's see, I already know my bottom part is x minus 2. Let's do the top part. Isn't this going to be 3x squared minus 4x? What's a plus 1 and a minus 5? There you go. Very good. Okay, we're almost done. We're going to do some factoring upstairs. Okay. I want to get a 3x squared in the front. So look, y'all, I'm going to put a 3x and an x. Plus 2 and minus 2. Boom. Thank you so much. Okay. Now, again, y'all, the way you could make sure that we wrote the numbers in the right way, we already know that 3x and x is going to give me 3x squared. I already know that plus 2 times negative 2 is going to give me the negative 4. I need to make sure that we are going to get a what? A negative 4x, right? What's 3x times negative 2? Anybody know? Negative 6x, okay? What's 2 times x? 2x. If you add them together, do we get that negative 4x? Okay, so that's how we know we did it right, okay? All right, question. What's going to cancel out here? X minus 2. Stop, go away. F prime at 2 is equal to the limit as x approaches 2 of 3x plus 2. What is that limit going to be equal to now, y'all? When you plug in your limit. There you go. And there's your limit. Tell me, John. Are we good? We're good so far? Okay, look, y'all. Same exact problem. The only thing we're going to do, we're going to use the other form. Okay? So look, we're going to use equation 3.6. So I'm going to write the equation for y'all, okay? So look, f prime at 2 is going to be equal to the limit as h approaches 0 of f of 2 plus h minus f of 2 all over h. Okay? Because that's this formula here. Okay? So I'm just plugging it in for what we got. Okay? Now, we're going to do some pieces. Okay? First off, do y'all remember what f of 2 was equal to? We did it in the first part. You can go back and scroll, or you wrote it down. Do you remember what f of 2 was equal to? When we plugged in 2, it was equal to 5, right? Okay, good. So that part, it's just the same part. We had done it earlier, right? It's not going to change. Now, what we are going to have to find, y'all, and I'm going to do this on the side, is we're going to have to find f of 2 plus h. Now, remember what that means. I'm going to come back to this expression or this equation right here, this function, and everywhere I have an x, I'm going to plug in a what? A 2 plus h, right? Okay, so we're going to go slow. 2 plus h squared minus 4 times 2 plus h plus 1. Okay? Two plus h, 2 plus h. Minus 8 minus 4h plus 1. 4, 2h, another 2h, and an h squared, minus 8 plus 4h plus 1. So far, am I doing okay? I'm just following that whole thing out. Right? What do we got to do now? Okay, we can combine like terms. 3, 4, 2h and 2h. 4h squared, or 4h. Guys, can I combine this minus 8 and that plus 1? to give me a -7. Okay, what's the next step? The 3, let's see, 12 plus 12h plus 3h squared plus 4h minus 7. Okay, almost done. Okay, let's see. I'm going to write it like this, y'all. 3h squared. I'll put the h squared coming first. Can we combine the 12h and the 4h? 16? Okay, what about a 12 and a -7? Plus? Okay. All right. So we got that part. Ah, guys, I made a mistake. Oops. I just saw it right now. What kind of 4h did I have here? Negative. Yeah. I got to fix this part. Sorry about that, y'all. Minus 4h. This here is a minus 4h also. This part right here is a minus 4h. Okay, so something's going to change, isn't it? An 8h positive. There we go. Better. Okay. Sorry about that, y'all. Okay. So now we got this piece right here. Okay, so let's come back and let's see if we can plug that in where we need to. All righty. So we're going to take the limit as h approaches 0 of f of 2 plus h, which we just found to be 3h squared plus an 8h plus a 5 minus, didn't we already say f of 2 was equal to what number? 5, so that's going to go right there, all over h. Okay. So this here is the limit as h approaches 0 of, let's see, well, those 5s are going to cancel out. So I'm going to have the 3h squared plus an 8h all over h, right? Now, remember, y'all, when we did the problem 2 underneath earlier, I said you got 2 ways of doing it. You can either separate the fraction and divide each of them by h, or you can factor out an h from the beginning. It's really up to you. What I'm going to do here is, okay, I'm going to go ahead and factor out that h from the top. So that this h here and that h there will cancel. And then we'll have the limit as h approaches 0 of 3h plus h. What is that limit going to be equal to? Did we end up with the same thing when we did the problem earlier? Did we get 8 also? Yeah, we got 8 also, right? Okay. So what are we really doing here, y'all? We're doing the same problem. We're doing it 2 ways. Let me ask you a question. The calculus part of it is doing the actual limit. Okay? The algebra part of it is doing this. What part is harder? Actually taking the limit or doing the algebra? It's more work, right? Because the limit, you know how to do limits already, right? Limits is not the hard part. The limit is once you cancel stuff out, plug that value in, right? The harder part, I think, is actually doing the algebra behind it. Okay. So again, guys, I'm gonna show you a little bit of how you if you feel like you need to review some algebra, especially when it comes to like factoring and stuff like that. I'm gonna show you how you can get to so basically ever since the pandemic, I have a YouTube channel and I have playlists for all my classes, right? So you can go through and you can say, hey, you know what? Let me go to this channel. Let me look for playlists, and then you can see where some of that stuff is in case you feel like you do need some extra review with it. Okay. We don't really have time to go through it in class because that is more review stuff, but that is the part where we kind of have to like shake some of those cobwebs off so we can make sure we understand what's going on. Now, again, y'all, remember what we're finding here. What we found is we found the slope of the line that was tangent to that graph, to that 3x squared minus 4x plus 1, when x is equal to 2. So the slope of the tangent line ended up being what number? Ended up being 8, right? So again, just to kind of give you a rough idea, what does that mean? That means that if I were to graph, what's the equation again? 3x squared minus 4x plus 1. So my graph is going to look, oh, I don't know, something like this. And it's going to probably do something like that, okay? And what we're saying is, suppose, I don't know, I'm going to make this up. Suppose right about here is x equals 1. I'm just kind of making this up. What we're saying is that if we were to draw a line that was tangent, if we were to draw a line that was tangent at that curve, the slope of that line would be 8 over 1. Now, think of the number 8 over 1. Look at that red line. It's going up, isn't it? So that's how I know it's positive. Not only is it positive, but that line is more vertical than it is horizontal. You know what I mean? It's steeper. And that's why it has a big value like 8. So if my slope would have been something like, say, 1/2, my line still would have been positive, but it would have been kind of cruising like this. Does that make sense? Right? And I don't know if you guys can see me as I'm doing this at home, those of you who are at home, but I think I'm coming up on the camera a little bit too. I hope so. I'm not certain. But anyway, let me do it this way. Just, I don't know. I think people are still watching from home. Yeah, we got a few folks. Okay. So let me show y'all something real quick. Boom. And let me do this so you guys can see. Whoa, buddy. Okay, guys. So what we're saying is, well, here we go. So since my slope was 8, my line was more upright, right? But if my slope would have been 1/2, still would have been positive. So the line still would have been going up, but it would have been more something like this. Does that make sense? So those of you guys who are watching at home, I just want to make sure you all can kind of see what it is I'm doing. Okay. So remember, positive line, the line's going to go up. But if it's a bigger number, it's going to be steeper. If it's a smaller number, it's going to be more horizontal. Okay. So come back here. Boom. And tell me, John. That's right. F prime of 2 is 8. We took the limit. We already did the limit right here. We did the limit as h approaches 0 of 3a plus 8. That's how we came up with 8. Right? We took our limit. Yeah. Okay. So guys, remember what the slope, what the derivative at a point is telling me. The derivative at a point is telling me the slope of the tangent line at that point. Okay. So I hope this is kind of giving you a little bit of like, all right, we're almost done, because look, now I'm picking problems from the homework, right? Okay, so look what it says. The graph of the slope of the red function has which color? Okay, so what we're doing, we're trying to figure out right now is we want to find the slope of the tangent line of the red graph. And then we're going to say which one of those graphs, the black, the yellow, the blue, or the green, is representing the slope of my tangent line of this red. Okay. So let me show you how we can do this. If I were to pick a point right here, and I were to find the slope of that point, the slope of the tangent line, would you say that that tangent line is positive? Because it's going up, right? And would you say it's relatively steep? Okay, so I'm going to make this up. Suppose that one there, I'm going to make this up, y'all. I'm going to call this M1. So M1, I don't know, let's say it's 10, right? I'm just picking random numbers. Okay, I'm going to pick another point. The blue one. Would you say, I'm going to call this one M2. Okay. Would you say the slope of that line is positive? Okay, is it more than 10 or smaller than 10? Smaller than 10 because it's not so steep, right? So what is it? I don't know. Let's say it's 5. Okay, I'm just picking numbers here, right? Okay, now I'm going to get rid of those two lines because I don't need them for right now. And let me do this one right here. Cool, and I'm going to call this one M3. What would you say the slope of that line would be? It's 0. Very good. Excellent. Good. I'm glad you said that. It's 0. That line, y'all, is not going up, so it's not positive. And it's not going down, so it's not negative. So we know it's not positive. We know it's not negative. Hey, the only choice we got, it's going to be 0. Okay? Horizontal line? Okay, so now look, let's do it. Let's try one more. Right, but hold on, John. I want to get to this problem. Now, I want to look at this one. I'm going to call this one M4. Okay. Would you say the slope of that line is positive or negative? Negative. Okay. So let's just pick a number. Now, it looks pretty steep, right? So I'm going to say it's, say, -5. But I'm going to do one more. Would you say this one is also negative? And is it more steep? Okay. So M5 would be something like, say, -10, right? So now what I want to do, these right here, y'all, are going to be my Y value of either the green line, the blue line, the yellow line, or the black line. I want you to notice we picked numbers as we were going from the left to the right because we started off over here and we moved in this direction, right? We said, let's pick a point over here. Let's pick a point over here. Let's pick this one. Let's pick this one. So we went from the left to the right, okay? So now, this is what we're going to do. As we go from the left to the right, my Y values are going from 10 to, say, 5 to 0 to -5 and to 10. And you can see, well, look, all these Y values are going down, right? Okay, so that doesn't help me too much. But remember what we said was happening right here? We said the slope of that line was what value? Which one has the Y value of 0 at x equals 1? The green, the yellow, or the black? The green, the blue, the yellow, the black. Sorry. The blue. The blue has a Y value of 0 because that's where it crosses the x-axis. So when I pick my answer, I'm going to pick blue. Okay. What did we say the slope of this line was right here? Okay, the slope of that line was 0, wasn't it? And that line had a slope of 0 when x was what number? -1. So that's telling me that my graph of my slope is going to have a Y value of 0 when x is equal to -1. This graph has a Y value of 0 when x is equal to -1. Right? So I want you to notice, look at all my graphs. My Y values were going down, but all these Y values are going down, right? Because they're all going from the top, they're going down this way, right? All my Y values are decreasing as I'm going this way. Okay, that helps me. But this part right here is going to help solidify which one of those is going to be my answer, right? Because I know that the slope right here is 0, so whichever one has an x-intercept right here is going to be the graph that I'm looking for. Okay? Again, y'all, remember what we're looking at. We're looking at the slope of the tangent line. So that's why I was drawing each of those lines, right? Now, let's do the same thing. We got one more, maybe two more here. Okay, so we're going to do the same thing here. It says which blue function, because these here, you can see the lines are all blue, is the graph of the slopes of the red function. Okay, so if we were to pick a point on this graph, and we were to say we want to find the slope of the tangent line, well, the slope of the tangent line now would be the line itself at that particular point. Okay, now let me ask you a question. Is this line going up or down? It's going down, right? Okay, now I'm going to pick another point over here on this side. The slope of the tangent line would actually be on the line itself. Okay, now let me ask you a question. Is this slope going up or down? Okay, Do you agree with me that these two lines have opposite slopes of each other? Like one of them is -3, one of them is +3, or one of them is -5, the other one is +5, right? So the slopes are the same, they're opposite values of each other. Say that they'll have the same absolute value, one is going to be negative, one is going to be positive, okay? Now guys, one thing I do want to mention, anytime we have a graph that has a point like this, there is no tangent at that particular point, okay? There's no tangent anytime you have a point in your graph like that. And we'll talk about that later in chapter 3 or 4. But anytime you have a graph and there's like a sharp point like that, it's not going to be differentiable at that point. So remember what we said. The slope here would be, say, something like -3, and this one would be something like +3. So what I'm going to do is I'm going to look at my choices, A, B, C, D, E, and F. I want to find the graph where the first part of it is negative, and then the second part of it is positive, but they're the same distance from the x-axis. So those distances are going to have to be the same. But remember, it's first starting off at negative, and then it's going to positive. Between A, B, C, D, and E, which one looks like it represents same absolute value, same distance, but one's first negative, then positive. So first negative, and then positive, and the distance between here and here has to be the same, right? It's just an abstract way to represent it, that's right. Now, I want you to look at that problem, and there's one more. Here we go. Almost the same type of problem, right? Okay, would you say, if we were drawing the tangent line here, would you say the slope here would be negative or positive? Negative. And this one here would be, okay. Now, you know they're not the same, right? You know they're not the same because this one here is less steep. And this one over here is more steep, okay? So we're first going to be starting with negative, and then we're going to be going to positive. But because the positive one is steeper, the distance between the x-axis and the positive is going to have to be a bigger number. So we're first going to start off with negative and then going to positive. So guys, if I was doing this, let's say by process of elimination, first doing negative, then positive, well, that's not going to work. And that's not going to work. And that's not going to work. I want to first be negative and then positive, for the distance between the x-axis and that positive value is bigger. Which one would I look at? So if you look here, are these two about the same? Yeah, okay, so we don't want that one. Is the distance, say looking at the two E and F, the distance from the x-axis to the positive part, we want it to be bigger. Would I pick E or would I pick F? E. And then you got it. Okay. Does that make sense? Okay. Go ahead. I'm going to keep doing what we got to do. Okay. So guys, that was 3-1, and I'm going to be real honest. It took me a lot longer to do 3-1 than I thought I was going to do. So we're going to do a little bit. We can finish 3-2. We'll finish it. If we can't, we'll wait till Monday. Okay, but we're going to try to do 3-2 because 3-2 is very similar to what we just did in 3-1. Okay. So I want you to notice something here. In 3.1, y'all, we use basically a version of this formula right here, right? But we were doing it at a particular value of A, right? A particular value of X, we're calling it A, so we did it at 3, we did it at 2. This is the more general form. So this is going to give me the derivative at any value. So once I know how to do this form, then I can just plug in values. Instead of plugging in the value to begin with, I can do the general form, and then I can find the derivative at particular points. Okay. So look what it says. Let f be a function. The derivative function denoted by. Does anybody remember how we say that? F prime. Good. is the function whose domain consists of those values of x such that the following limit exists. So we're going to say f prime at x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. And it says a function f of x is said to be differentiable at a if the derivative at that particular value exists. More generally, a function is said to be differentiable on S, which is my interval, my open interval, if it's differentiable at every point on an open set F. Okay. So let's see if we can figure out what we're going to do here. I'm going to use this equation right here, y'all, to find my derivative of f of x equals the square root of x. Okay. So look, I'm going to start writing it out for f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x, okay, all over h. Okay? And we're going to go super slow, y'all, so that we are good here. Okay? Okay, the first thing we're going to find, y'all, we're going to find f of x plus h. Now, remember what that means. That means I'm going to come back to my original function, and everywhere I have the letter x, I'm now going to replace it with an x plus h. So that's equal to the square root of x plus h. That's all we did right here. Because f of x equals square root of x, replace the x with an x plus h, square root of x plus h, right? Minus f of x. Well, f of x is equal to the square root of x all over h. Right? Okay, so y'all, I want to say that in somewhere in chapter 2, it might have been like 2.3 or 2.4, one of those sections, I know it's one of those, we did something when we had to use conjugates, right? And I told you, you're going to use conjugates when you have square roots. And so I'm going to kind of do this on the side, just real general. If you see an expression like a plus b, then the conjugate is going to be a minus b. Okay? Or if you see something like a minus b, the conjugate is going to be a plus b. Okay? So what I mean by that is when I look at this part right here, I'm going to think about that as my a and that is my b. And look what we have in the middle. We got a minus, right? So what we're going to do here, y'all, is we're going to multiply the top and the bottom by the square root of x plus h plus the square root of x, both upstairs and downstairs. Okay? Because that is the a. You're not changing the a. You're only changing the sign in the middle. Okay? So now we're going to go super slow motion here, y'all. Look, the square root of x plus h times the square root of x plus h, still x plus h, right? The square roots cancel each other out. Now, we're going to go here. So we're multiplying a square root of x plus h times the square root of x. And you know what? We don't even need to do all of that. Let's just write it like this for right now, okay? And it's a plus because this was positive and that was positive, right? So I'm not even going to distribute. I'm going to show you why I'm not going to distribute it now. But look, let's do the same thing here. The negative square root of x times the square root of x plus h, isn't that just a negative square root of x plus h times the square root of x? And then finally, the last one, a positive square root of x times a negative square root of x is just a negative x, right? Because the positive times the negative is negative. The square roots are going to cancel each other out. All of this, y'all, is still being divided by h, and I still have that square root of x plus h plus the square root of x on the bottom part too, right? Because I still got this one down here. And I'm not going to worry about that guy right now, okay? Now, question. What's going to happen to this piece here and that piece right there? That's right. They're going to cancel out. So we're going to get rid of those. Is anything else on the top going to cancel? The x's, right? Look, this x here and that x there are going to go away. So what's the only thing we're still left with upstairs? Good. So we're going to have f prime of x is equal to h. Now on the bottom, I have an h, a square root of x plus h, and a square root of x. Oops, I forgot something right here, y'all. Let me fix this. Okay, forgot to write my limit. Okay, anything else going to cancel on the top and on the bottom? The h's. So let's get rid of this h here and let's get rid of that h there. So f prime at h, or f prime at x, is equal to the limit as h approaches 0 of 1 over the square root of x plus h plus the square root of x. Okay, let me ask y'all a question now, y'all. As we take the limit as h approaches 0, what's going to happen to that part? It's just going to turn into 0, isn't it? So you agree we can get rid of that? So wouldn't we have 1 over the square root of x plus another square root of x? Because if h is going to 0, this piece right here is going to end up going away, isn't it? So I'm just going to be left with a square root of x. What's the square root of x plus another square root of x? 2. Very good. Remember, we're adding them now. So now we end up with f prime at x is equal to 1 over 2 square roots of x. Now, what's the difference from what we did here compared to what we did in 3.1? In 3.1, we were doing the derivative at a particular value. Here, what we're doing is we found the derivative. Now, we want to find it at a particular value. All we would have to do is plug that value into that expression. Does that make more sense? So in 3.1, y'all, we were doing it for, let's do it for 3, let's do it for 5, let's do it for 2. Here we have the general form, and now we can find an infinite number of derivatives because we can plug this thing in as for any values that we want to, right? As long as they're defined, as long as they're in the domain. You know what I mean? Since I'm dealing with a square root, I couldn't put negative numbers. Since I have a square root of x on the bottom, I can't do 0, so I'm going to do positive numbers only, right? Okay. So let's try doing the same thing on this next problem. We're going to go about the problem exactly the same way, y'all. So look, I'm going to write the general form of what it is we're trying to find. We're trying to find f prime of x. And I'm going to write out the whole thing so that you know when you're doing this, how do I write this out? And I'm going to give you all some pieces of information just so we have it. Oops. Okay, here we go. Okay, what I have right here in the green, y'all, we call this a lot of times the difference quotient. Okay, called the difference quotient. That f of x plus h minus f of x over h, that's just the term they use, the difference quotient. So remember, what does the difference mean I'm doing? Oh, I'm subtracting, right? What does the quotient mean we're doing? We have a fraction, we're dividing. You can see there's a minus sign in the middle. You can see we got a big old fraction. That's why it's called the difference quotient, okay? Now, again, y'all, what we're going to do this for this particular function. So the first thing I need to do is I need to find f of x plus h. Now, remember, my f of x is already right here, y'all. It's x squared minus 2x. Okay, so I'm going to write this out real slow. I'm going to write this as x plus h squared minus 2 times x plus h. So remember, all I'm doing here, y'all, is everywhere I have an x, I'm replacing it with an x plus h, okay? Now, just like we did before, I'm going to write it as x plus h times x plus h. I'll go ahead and distribute that -2 to give me a -2x and a -2h. All right, let's go ahead and FOIL this guy out right here. So x and x, that's going to leave me with an x squared. X times h is just an xh. H times x is still an xh. And h and h is an h squared. All right, let's see what we can combine. Y'all agree we can combine these xh's right here? So xh and another xh, wouldn't that be a 2xh plus h squared minus 2x minus 2h? So at that point, guys, I don't think I can combine any other terms because I don't have any other like terms, okay? So this expression right here is our f of x plus h, right? So look what we're going to do. We're going to write it out. We're going to say f prime at x is equal to the limit as h approaches 0 of that whole thing, x squared plus 2xh plus h squared minus 2x minus 2h minus, we still got to subtract our original function, f of x. Yeah, and guys, I'm going to write that in parentheses because I am subtracting the entire piece, okay? Okay, so I'm running out of room, so I'm going to do this over here a little bit on the side. So I'm going to have x squared plus 2xh plus h squared minus 2x minus 2h. Let's go ahead and distribute that negative to leave me with a minus x squared and a positive 2x all over h. Alrighty. Now let's go ahead and go through and see what parts can we cancel here. X squareds, let's get rid of those. Anything else? Can we get rid of the 2x's? Yeah, the 2x's as well, right? That 2x and that 2x are going to go out. Okay, so now we have f prime of x is equal to the limit as h approaches 0 of 2xh plus h squared minus 2h all divided by h, right? Now, guys, remember when I told you, when we're getting to this part here, you have a whole lot of options, right? You can factor out an h at the top, or you can say, look, when I'm dividing by h, what am I dividing by h? I'm dividing each individual piece on the top by h. So if I were to cancel this h, I'd have to cancel it with that one there. I'd have to cancel it with one of those two right there. And I'd have to cancel it with that one as well, right? Because I'm dividing each individual portion. Does that make sense? Okay. So now we can take the limit as h approaches 0 of 2x plus h minus 2. So let me ask you a question. If you were to take the limit, so guys, this part right here, what we're doing right now, this is the actual calculus part. The rest of it, all we're doing is really algebra. Now again, I understand that, you know, we might be a little rusty with algebra, but I really want to emphasize is if that's the part that we got to focus on, then we can focus on that outside of class, right? And I'm going to give you some tools to show you how you can do some of that stuff. But what I really want to emphasize here is this is the part where I'm actually going to do the calculus, is actually taking the limit. So now, if we take the limit as h approaches 0, do y'all agree that that piece is basically going to go away? Wouldn't we just be left with 2x minus 2? And this here, y'all, is my f prime of x. That's my derivative. Yes, of course. Yeah, and remember, I'm also recording it too. Yeah, so you'll have access to the video. And guys, I'll upload the video to YouTube this afternoon. Okay, so you'll definitely have access to that. Okay, so again, I know the algebra is a lot. I'm not going to try to tell you it isn't, because it is, right? It is a lot. So look, I want to zoom in because I want to talk about a couple of things. So first it says we use, and I'll zoom back out a little bit so you guys that missed it can copy in a second, but it says we use a variety of different notations to represent the derivative of a function. So we found the derivative of f of x equals x squared minus 2x to be f prime of x to be 2x minus 2, right? We just found that derivative. Okay, so y'all, if we would have called that equation y equals x squared minus 2x, then we would have said the derivative is y prime, okay? So this right here is y prime. Why? Because it has a little apostrophe on it. You know what I mean? The way we read this is dy over dx. That means we're taking the derivative of y with respect to x, okay? These are all just different names. Like I said earlier, Antonio, Tony. If Tony's a real big guy, big T, right? Something like that. You know what I mean? They're all the same. They all mean the same thing. They're just different ways of naming it, okay? The derivative of this function with respect to x is equal to 2x minus 2. These are just different notations, different ways of expressing the derivative, okay? They all mean the same thing. F prime at x, dy over dx, y prime, the derivative of f with respect to x. They all mean the same thing. They all mean the derivative, okay? And then if we're talking about the derivative of a particular point, sometimes I'll write it like this. The dy over dx when x is equal to 8, okay? But they all mean the same thing. Let me zoom out because I think some of you guys were still copying, and then we'll go on to the next slide. Okay, so guys, I'm gonna take a quick look here, and I'll tell you what. Let's put a pause right here because again, Monday was, I forgot my power cord, so if we would have done what we are supposed to do Monday, we would have been done probably with 3.2, I don't know, 30 minutes ago or so, because we would have done a big chunk of 3.1 on Monday. So I'll tell you what we're going to do. We're going to put a pause right here. And so let me do this real quick. Let's see. I know some of y'all are watching at home as well, so I'm going to keep you guys here watching at home. But, so this is one thing I want to do. This, again, guys, is just so that if you want extra help, right? So when you go to our playlist, if you click on my name right here, you should be able to see playlists, okay? And again, guys, all this is getting recorded, so you'll have access to it. But if you want to write stuff down, you can do that. If you go to playlists, so right here, there's one, it says MATL 0014. If you click on view the playlist, okay, so you see this one right here, it says multiplying polynomials. If you click this one here, this is where you're going to see stuff like, let me let this little thing go. Okay, skip that. And there's another whole lot of volume. Review the volume. That's so weird. That's so I don't know why it's not there. Let's see. But I show you basically, okay, here we go. Let me zoom out a little bit or maybe move along this way. I'm trying to find one where, but there should be something here, y'all, where I'm doing like, I mean, this is again just basic multiplying stuff, right? When you get to this one, 13.4, it was working yesterday. But anyway, this is where I do all the factoring. Okay, so if you just go to that stuff, you'll be able to find factoring videos there, learning how to multiply. Again, it's just if you need extra help, look for it. Okay, it'll be there, or just YouTube it, search it. Okay. So guys, the other thing I'm going to do is this real quick. Let me go to my weekly activities folder. I'm going to go to week 3. And what I'm going to do, y'all, is I'm going to extend the deadline date for this one to, instead of being due next Wednesday, I'm going to make it due next Monday, which would be, oh, okay, there you go. So I made it due next Monday since we haven't finished it yet, right? We'll finish it on Monday, but I just wanted to give you a heads up there, and I will even change that right here. Yeah, we're not doing the discussions. Yeah, the discussion. I mean, if you wrote something in, that's fine, but don't worry about it. I mean, our grades are basically going to be homeworks, quizzes, and a test. The discussion stuff was mainly like that's really for more of like a traditional online class. You know what I mean? And then, guys, the other thing I wanted to mention, and I am still recording, but guys, so like last semester I had a statistics class, and sometimes people were like, the students would help each other as well. So what I want to point out is on our pronto chat, right? So guys, I do have 3 in-person classes. Y'all's class the only one I have today, but Tuesday and Thursday I do have 2 of them. They're all late in the afternoon. And I know somebody messaged me yesterday. Jennifer, there you go. She messaged me last night. I didn't, or yesterday afternoon. I was in one room. Let me go ahead and stop recording. I was in one room and